Okay, the next example is an example with trig stuff in it. It's got a cos and sine in it. It's example number 10. If you look back to one we did earlier, we did another one with trig on it. It's called example number 4. And we did it a slightly different way. And it's common that when you're doing these trig ones, a slightly different approach might help. First of all, what do you think u might be? You'd be given it anyway in the example. What do you think u might be here? Well, just the sine x. Okay, just the sine x. And then, can you spot anything that you could do from there which will give you something that also appears over here? If you differentiate that, so if you get du dx, what do you get? Cos x, which also appears over here in the question. And that often happens with these trig things. And if you spot that, then there's no need to do the normal stuff about writing it as x equals, which will again give you inverse sine and just gets nasty. So we'll go straight now to rewriting our question. It's the integral of cos x, but cos x I can replace with du dx. Sine x cubed is u cubed, and then I have up here a dx, which I'll just write down, and hopefully something nice happens. And here it's that those dx's will cancel with each other, so we are left with a really straightforward integral of u cubed du.
Do we have written down anywhere the differentiate of sine x?
You should be doing it with Mr. Carey, but otherwise it is one that I think you have to learn. I'm trying to think. I don't think this differential and integration of sine and cos are in the formula book. I'm looking, they're not. So you do have to learn those. I think we went through them as a class when we were doing integration by parts. I think we wrote them down at that point. If I just look back in my notes, when we were doing integration by parts, we wrote down a whole load of them, which you can see here, how sine and cos differentiate and integrate, and if there's some multiples there as well. So we did that when we were looking at integration by parts. But you will spend more time on it with your other teacher. So doing this integral over here, add 1 to the power, divide by the new power. I've done my integration, so stick my plus c down. And then simply say, well, u, that's sine x, because you need to put it back in x's, to the power of 4 over 4 plus c. Job done. So sometimes with the trig, if you can spot that if you can differentiate one bit to get the other bit, that makes life easier. Now I said earlier on, we're hoping we'll get another red box rule from this. What I'm going to do now is write down question 10's question and solution, and question 4's question and solution. So question 10 was this: the integral of cos times by sine cubed x, and the answer was sine x to the power of 4 over 4 plus c. The other one we had like this was number 4, which was sec squared x tan squared x dx was tan cubed x over 3 plus c. Now it might be useful as well if you get your formula books out and find in your formula books page 5, and then hopefully I can point something out to you, unless you can spot it even yourself. Number 10 is the easiest one to maybe spot what's going on, but it does work in number 4 as well. If you just look in your formula books on page 5, what is the derivative of tan x? If you differentiate tan x, which means on this page you're going from the right hand column to the left hand column, what do you get if you differentiate tan x? Sec squared x, yeah. What do you get if you differentiate sine x? Cos x. Can anybody spot anything which may be happening here? Any pattern? I know it's just from those two. The second is the integral of the first. Okay, I was going to say it the other way around. The first is a differential of the second, but yeah, that's exactly right. So then what happens, Billy? So you've just said at the moment, if you've got the second one here, I've said the one on the left of it, the first one is its derivative, so that's f dash x, and we're integrating this. Well, it's not quite true. What did I had a power here, so I'll put a power there. Both of these lines fit this rule. There was a function, there it was sine x, and that had a power on it, and written immediately in front of it was the derivative of that function. If we look at this one, our function f of x here was tan x. It had a power on it that was 2. And written right in front of that function was the derivative of that function. These are what we ended up with over here. So can anybody reckon they can tell me what the right-hand side of this is? And this is going to be a new red box rule.
f of x to be n plus 1 over n plus 1 plus 3.
That's exactly right. Okay. So, what we have here, if I go through that, let's put that there a minute. Okay. If you have a product, basically two things multiplied together, one of them is a function of x with a power on it, and the other one is that same function's derivative, which both of those were there. The top one, my function was sine x, bottom one, my function was tan squared x. Then on the right hand side, it is that function to the increased power divided by that new power with your plus c. Okay. And again, that's a very useful formula to remember. And if I look back now at question 5, which is one we did earlier, question 5 was this. This was question 5. If I'm telling you this is pretty much fitting that rule, but we may have to do a little fiddle, like we've done little fiddles and things before to make them fit rules. What do you think in this integral here is going to be the f of x bit, the function bit then?
The x squared bit.
I'm looking for a function and I'm looking for its derivative. So which is going to be the function, which is going to be, yeah, that bit there will be my function. It's to a power. What power is that to here? Half, yeah. And over here, well, what's the derivative of this bracket here? What's the derivative of that function? What's the derivative of x cubed plus 5? Okay, we actually haven't got the 3 at the moment. Okay, that 3 is a bit of a problem. We haven't got that 3. So what do I need to do to make those two lines equal to each other? The third in front. Okay. So now, what we've got here is my x cubed plus 5 is my f of x, and that's to a power. The power there is a half. Over here, my 3x squared is my f dash of x, and I had to introduce that 3 so it would work. Well, that's fair enough, I can just divide by 3 to cancel it out, so I haven't actually changed anything there. So if we've done that, can anybody just use this new red box rule and just tell me straight off, without looking back at what we actually did with question 5 when we did it the long way round?
It was question 8.
Was it question 8? Mm-hmm. Oh, sorry, thank you, okay. Okay, can anybody tell me what, using this red box rule then...
Question 8 wasn't.
Was it question 5?
No, I don't know.
Question 9. Oh, right, okay, question 9. Maybe it was question 5 last year in the notes. Right, okay, question 9. Can anybody tell me then, just using this red box rule now, what the answer will be? Corey? Say that again, please. Go on.
X cubed plus 5 bracket over 2 over...
So the bracket with an increased power, which is what you said, yep,
over
divided by the new power, and I need a plus C, and I need this third here that I introduced as well. Okay. Okay. Yeah, dividing by 3/2 is the same as timesing by 2/3. So I got there a third times by 2/3, which would give me 2/9, and then you should find that that is what we had written down earlier for number 9 before we put the square root sign version of it in there. So that works. Okay. So that's that other red box rule. I just want to remind you at the same point of another red box rule we had. It's not new, but it's similar, it's sort of linked together. Also remember, we had, if we had a fraction with a function on the bottom and its derivative on the top, and we were integrating it, then we had, that was log of our function plus C. So that's just a reminder of a previous one. It's actually a special case of the top one we've just had, that when the power is -1, because you'd end up dividing by 0 and that wouldn't work, and that's why we have to go into logs. So those two are linked. The bottom one is when the top one doesn't work, because the top one doesn't work when n is -1, because you divide by 0. Okay? So that's just a recap there of an older one which we have already seen. Yeah. Okay, and I will stop there, other than to say, if anyone's watching this later on, you should now in the book be able to do everything up to and including 2D as an exercise.